Math 3, Formative 1, Module 4, Part 2. So you may be thinking, why are we going out of order? The way we split this unit because of e-learning, we actually are doing Lesson 3 and Lesson 4 from one chapter, followed by Lesson 1 from the second chapter. So that's why it seems like we're a little out of order, and we did 3 and then 4 and then back to Lesson 1. So just kind of bear with me on that. On all of these problems, we are going to solve each equation for all radian measures over the domain 0 is less than or equal to theta, which is less than or equal to 2 pi. So on number 1, the sine theta is already all by itself on one side of the equal sign. And since sine is always y values off of the unit circle, we're just going to scroll down and look for y values that are root 2 over 2. So y values that are root 2 over 2. So that happens at pi over 4, and that happens at 3 pi over 4, and that should be it. So pi over 4 and 3 pi over 4 are our answers. Theta equals pi over 4, theta equals 3 pi over 4. So 2 answers. On number 2, we want to get the cosine all by itself, and it's currently being squared. So we're going to need to square root. The only way to undo something squared is to square root. So square root the left side, square root the right side. So cosine theta equals, and then whenever we introduce a square root into an equation that we're solving, we want to add the plus minus symbol. So the square root of 1 is plus or minus 1. Cosine is always going to be x values off of the unit circle. So we want to find all the radian angle measurements that are 1 or negative 1 for the x value. So 1 or negative 1 for x values. So 1, it happens at 0 and at 2 pi. And then we said 1 or negative 1. So then it also happens at pi, and then that should be it. So 0, pi, and 2 pi. So theta equals 0, pi, and 2 pi. So all 3 of those answers. On number 3, we want to isolate sine theta by doing order of operations backwards. So we're going to subtract 5 from both sides of the equation. And then we're going to undo multiplication by doing division. So then we're left with sine theta equals negative 1/2. So sine is always the y values. So we're looking for y values of negative 1/2. Y values of negative 1/2. So that happens at 7 pi over 6, and that happens at 11 pi over 6. So theta equals 7 pi over 6 and 11 pi over 6. On number 4, they have already factored for us. We have 2 sets of parentheses being multiplied together. So we're just going to set each factor equal to 0 and solve for x, just like we would any equation. So I'm taking one set of parentheses and setting it equal to 0, and then I'm taking the second set of parentheses and setting it equal to 0. And then we solve like normal. So on the equation on the left, I want to isolate the cosine theta by doing order of operations backwards. So I have to subtract root 3 from both sides of the equation. And then in order to undo multiplication, I'm doing division to get cosine theta equals negative root 3 over 2. And then cosine is x values. So I'm looking for x values of negative root 3 over 2. So x values of negative root 3 over 2. So that happens at 5 pi over 6. And that happens at 7 pi over 6. So 5 pi over 6 and 7 pi over 6. Then, looking at our other equation, right, don't forget about that other one, we want to isolate the sine theta, so you have to add 1 to both sides of the equation, and we get sine theta equals 1, and then sine is y values, so I'm looking for y values of 1. Y values of 1. So there's one right there at pi over 2, and I think that should be the only one. Let's see here, so pi over 2. So theta equals pi over 2. So since these were all a part of the same equation, we have multiple answers. These are answers, and so is this. And then that's it.